Today, we're going to pull back the curtain on the magic that connects our entire world. So if you're new to IT, maybe you're working in support, or you just really want to nail that network admin interview, you are in exactly the right place. We're going to break down the absolute fundamentals of networking, starting right now. I mean, it really feels like magic, doesn't it? You click on a link, and poof, a website just appears on your screen. But what is really going on in those few seconds? Well, it's an absolutely incredible, high-speed conversation between countless bits of hardware and software. And we're about to decode it all together. So here's how we're going to tackle this. We'll break it down into 4 simple parts. First, we'll get the big picture of our connected world. Then, we'll dive into the digital addresses and languages that let all our devices talk to each other. After that, we'll get hands-on with the actual hardware. And to finish up, we'll see how it's all put together and, more importantly, kept secure. All right, let's start with the absolute basics. To really understand how networks do what they do, we first have to figure out what they are and the different sizes they come in, from the network in just your room to one that spans the entire globe. So, at its most basic level, a network is really just a bunch of devices talking to each other. A great way to think about it is like a classroom, where all of the students can talk and share ideas. A network does the exact same thing for your computer, your phone, and your printer, letting them share things like files or one single internet connection. Okay, so what happens when all those devices are huddled together, say inside your house or maybe a single office building? Well, that's what we call a local area network, or LAN. And because the distances are so short, LANs are super fast. They're perfect for zipping files around and connecting to printers quickly in a small space. But what if you need to connect your office in Delhi with another one all the way over in Mumbai? That's way too big for a LAN. That's where a wide area network, or WAN, comes into play. WANs are built to cover huge distances. And you want to know what the biggest, most mind-boggling WAN of them all is? It's the internet itself, connecting billions of devices across the entire planet. So really, here's the key takeaway, right? It's all a trade-off between size and speed. LANs are for your local stuff, and they're crazy fast. WANs connect the whole world, but because of those huge distances, they're naturally going to be a bit slower than your local network. All right, so we get what a network is, but how in the world do all those devices actually find each other and have a conversation? Well, it's all about having a clear set of digital addresses and languages. Think of them as the official rules of the road for the internet. Every single thing on a network, I'm talking your laptop, your phone, even your smart toaster, needs its own unique address. We call this its IP address. It works exactly like a mailing address for your house. Without it, all the data flying around would have no idea where to go. But let's be honest, who wants to memorize a bunch of long, random numbers? Nobody. Thankfully, we don't have to. That's where the domain name system, or DNS, comes in. Just think of it like the contact list on your phone. You type in a simple name, like google.com, and DNS instantly looks up the right IP address for you. Honestly, it's a total lifesaver. Think about it. When you're sending something important, like an email or a big file, you want to be 100% sure it gets there safely, right? Well, that's the job of TCP. It's a protocol that carefully checks to make sure all your data arrives in the right order with no mistakes. It's just like getting a delivery confirmation for a package you sent. But then there are times when speed is everything, and a little imperfection is okay. That's where UDP shines. It just blasts the data out as fast as possible. No questions asked, no confirmations needed. It's kind of like a live video call. If the image glitches for a split second, you don't care. You just want the conversation to keep flowing. That's why it's perfect for streaming and online gaming. So it really boils down to this simple trade-off. You want perfect, totally reliable, error-free delivery? You're going to use TCP. But if you want blazing fast speed for your game or your video call, then UDP is your go-to, the right tool for the right job. And that's not all, of course. There are a few other key languages you should probably know about. HTTP and its super secure big brother, HTTPS, are what your browser uses to pull up websites. FTP is an old-school workhorse for transferring files. And DHCP? That's the handy little guy that automatically gives your device an IP address when you connect to a new network. Okay, so we've talked about all the invisible stuff, the concepts, the protocols, the languages, but what about the actual boxes and wires that make it all happen? Let's take a look at the physical hardware that makes all this digital chatter possible. Okay, first up, the router. This is basically the traffic police of your network. Its number one job is to stand at that busy intersection between your local network, your LAN, and the giant sprawling internet, the WAN, and make sure all the data gets directed to exactly the right destination. Now, if the router is the traffic cop for the whole internet, a switch is more like a clever mail sorter that works inside one office building. It connects all your local devices together. So when your computer needs to talk to the printer, the switch makes sure that conversation goes directly to the printer and doesn't bother anyone else. It keeps your local traffic fast and efficient. So you might be wondering, how does the internet even get into my house in the first place? That's the modem's job. It's a translator. It takes the specific type of signal coming from your internet service provider's line, whether it's cable or fiber, and converts it into a digital signal your router and computer can actually understand. And of course, you gotta plug all this stuff together, right? That's where Ethernet cables come in, and believe me, they are not all the same. For most of us at home, a Cat5e cable is going to be totally fine, giving you speeds up to 1 gigabyte. But in a modern office, you'll probably want at least Cat6 for faster performance. And in serious data centers, where speed is king, they're using Cat7 and even Cat8 for absolutely mind-blowing speeds. Okay, we've got all the pieces of the puzzle now. The ideas, the rules, the hardware. For our last section, let's put it all together and talk about how these networks are designed, and, critically, how we keep them safe. Every network has a blueprint, a layout, which we call its topology. The one you'll see pretty much everywhere, like in most offices, is the star topology, where everything wires back to a central hub or switch. But for ultimate reliability, you have the mesh topology, where devices have multiple paths to each other. If one connection goes down, the data just finds another route. And that, right there, is basically how the entire internet works. Super resilient. And last, but definitely not least, let's talk security. Your firewall is the digital security guard for your network. It stands at the main entrance, inspecting all the data coming in and going out, and it will block anything that looks remotely suspicious or dangerous. This thing is absolutely your first and most important line of defense against threats. All right, let's boil this all down. If you're heading into an interview or just want the core concepts, here they are. A network just connects devices to share stuff. LAN is local and fast. WAN is wide and global. IP is the address. DNS is the phone book that looks it up. Routers connect different networks. Switches connect devices on the same network. And firewalls? Firewalls are the security guards that protect the whole thing. So there you have it. Those are the fundamental building blocks that make our connected world tick. It's this incredible dance of addresses, languages, and hardware all working together. So the question I'll leave you with is this. As we start connecting everything from our cars to our coffee makers to the internet, what do you think is the next big challenge in making sure it all stays fast, reliable, and most of all, secure?